Okay, so that is recording. So welcome once again back to geometry. Oh, that's frozen, that's why. Here we go. Okay, so we have this angle that is similar to yesterday's class, what we talked about. What type of angle are we dealing with here? Alex?
An acute angle?
An acute angle. How do you know it's an acute angle?
Because it's smaller than 90 degrees and it doesn't have the little reflex thing.
So this angle is smaller than 90 degrees. We're looking in between these two, and because it's not the reflex on the outside of the angle, what other types of angles do we know? Oh, we talked about yesterday. Obtuse angles. What is an obtuse angle? So it's bigger than 90, less than 100. That is an obtuse angle. What other ones do we know? Right angle. What's a right angle?
90 degrees.
90 degrees. What is a reflex angle?
Isn't it larger than one? Yes.
Larger than 180, but less than 360. Good. We had two other ones. What is a straight angle? It's 180. It's a straight line that is 180 degrees. And the last one, what's a round angle? A total 360, all the way around back to where it started. So those are different angles we talked about yesterday. Now, let's name this angle we have. What is a good name you can give this angle, Alex?
Angle theta.
Angle theta. So that symbol inside the angle, that means theta. So you can call this angle theta. Good.
With a T?
With a T. T-H-E-T-A. Theta. What else could you name this angle?
G-E-O.
G-E-O. Angle G-E-O. Yeah, so you're using the triple letters. Angle E is another name. Just using the vertex because it's easy to see which angle we're talking about. We're not talking about, well, I have marked it before, but without this, it's easy to see which angle we're talking about. And because we're just talking about that single angle, there's not multiple coming off of this vertex. It's easy, we can just call it angle E because that is our vertex. Anyone can think of any other names? OEG. So if you can use the triple letters, it doesn't matter which order they come in as long as that vertex is in the middle. And OEG and GEO are both good names. Awesome. Any other questions from yesterday before we get started? Yeah. All right. So today we are going to talk about transformations. So transformations. When I say the word transformation, what comes to your mind?
Transformers.
Transformers, like the robots. Yeah. What else? So everyone instantly jumped to Transformers.
I think of like something going to something else. Like
Something becoming changing into something else.
The corny 90s movies are like they remake the JBW.
Corny 90s movie.
Princess Diaries when Princess Mia becomes a nance, or she called that. And then
Princess Mia becomes a princess. Whatever she's looking for. Okay. So transformation, that means to change. That is a similar definition of what we use in mathematics. So when we talk about transformations in math, we're talking about, this refers to a change in the shape and position of the image from one form or location to another. So you're taking some object and you're changing it somehow. You're either moving it, you're throwing it somewhere, you're spinning it, I don't know. You're changing it, making it larger, smaller. Those are all different ways to change it. And so those are all considered transformations. And so I have this star here. What are some things I could do to this star to transform it? What was that?
Square.
So I could turn it into a square.
Yep.
That would be considered transformation. That won't be necessarily what we'll talk about in geometry, though. We'll specifically work with 4 specific transformations that we'll talk about. We'll talk about 2 today and 2 tomorrow. And those 4 transformations will have certain rules that we'll talk about. But what are some things I can do right now to this star that would be considered transformation? I can turn it. So I can take it and I can turn it like that. That'd be considered transformation. What else can I do with it?
We
I can make it tiny. I can take it and I can shrink it really small. What else?
Bigger.
I can make it bigger. I can make it huge. Oh, I lost it. There we go. Can make it big. Anything else?
Wider.
Can make it wider. If I can mess up my star a little bit already. Okay. Anything else? What if I do this? The transformation. So I can move it. I can slide it someplace. That's another transformation. Now I lost it. Okay. But those are all considered transformations. Here. Once again, transformation is when we change a shape. And so when we change it, sometimes it's hard to tell what was the original and what was the new one. And so in order to help us know which one we're talking about, we have these two words, pre-image and image. So the suffix pre stands for before. Like you take a pre-test, it's before you. It's a prefix, it comes before the word, yeah. So pre is a prefix. So pre-image is the image before it was changed. So before you do any transformation, before you change it at all, before you move it, slide it, spin it, whatever you're doing, pop it, it's a pre-image. After the transformation has occurred, it becomes the image. So once it becomes a new shape, a new figure, a new object, after you did whatever you did to it, that becomes the image. So if I'm ever talking about the pre-image, I'm talking about the shape before. When I'm talking about the image, it's the shape after. Okay, with this simple, easy vocab stuff. All right. Along with pre-image and image, sometimes we have pictures. And how we denote which one is the new one and which one is the old one in the pictures is by these things called primes. They're like little symbols. They look at these little apostrophes right here. So these apostrophes represent these primes. And so when we start with the figure, we have A, B, C, D. That's our pre-image of our square. It undergoes some transformation and ends up over here. So this is the same square, except now those letters have changed. This is now A prime, this is B prime, C prime, D prime. And so when we undergo a transformation, in order to let us know which square is the old one and which square is the new one, we take those points of the square and we turn them into the prime points. So we have our A prime, B prime. You can keep going. We can do another transformation. So I'm going to take my image, now I'm going to do another transformation to it. I'm going to get another square. So I have this one. Now rather than just being A prime, this is now A double prime, B double prime, C double prime, and D double prime. I can keep going again. I can get A triple prime, so on and so forth. But this lets us know which transformation we've gone into. Which one are we talking about? Are we talking about the first transformation? Are we talking about the second transformation? Those primes help us know which shape it's from. If you were to, this shouldn't ever happen, but if you were to get, say, 57 transformations, you could do A prime 57 would be a way of writing it. You shouldn't, rather than having to do like 57 dots. That should never occur, but if that were to occur, that's a thing you could do. If you're just too lazy to do like 4 dashes or something. You shouldn't ever get more than 3 transformations or 4 transformations. But it would occur. So yeah, those are transformations. That's how we denote which one is which. So today we're going to talk about 2 transformations out of our 4 main ones, and then tomorrow we'll talk about the other 2. So our first transformation we're going to talk about is probably, in my opinion, the easiest one. This one's called translation. So translation is when you take an object and you slide it. You move it in a direction. It doesn't matter which direction. So you take the pre-image and you move it in some direction. The only thing, or the biggest stipulation about translation, though, is it can't change the object at all. It can't change the shape. It can't change the color. It can't change the size. I'm sorry? Just the position. That's the only thing you're changing. So I'm taking this car, and I'm sliding it over there. That's fine. The only thing that is changing is where the car was located. The car has not changed at all. It's not a semi-truck. It's not smaller. It's not larger. It's still the same car. So that's translation. We have a fancy word for meaning the same in mathematics. when we're talking about two things being the same, we use the word congruent. So congruent. We'll talk about this more specifically when we talk about triangles later on, but that is important for that'll come up a lot in geometry. And so this car, my pre-image and my image of my car are both congruent. They're both the same. The only thing that's different is where they're located. We okay with translation? Enough. Number 2 is reflection. So reflection is, as a sound, you're taking objects and you're reflecting it to a new object. So your transformation is you take an object and you flip it. You flip that pre-image over a line. That line is called our line of reflection. Easy to remember. The object, once again, it doesn't change. It doesn't change shape. It doesn't change size. The pre-image and the image, they're going to be the same. Just as if you were to look in a mirror, it's not going to show you someone else. It's not going to change who you are. It's still you. It's just a reflection of yourself. And so, just like reflection, once again, both shapes will stay congruent. They'll stay the same. Their sides will be the same. Their angles will be the same. That's fine. That's what we want. Another thing to notice is the distance. So these two objects, their distance from that line of reflection will stay the same. So say this lady is 4 feet away from that line. Her reflection would be 4 feet away from the line on the other side. So that distance should always be important. Next week, we're going to practice with graphing them and drawing these transformations, and this will be an important thing to remember. It's being able to remember that they're equidistant apart. So this lady reflected over here is the same distance from that line of reflection. Yes, so we had a problem in our SLO about reflecting a square, I think, over a certain line. That's what we'll talk about next week. So we'll learn how to do that. So you'll be able to answer one question all day in the SLO. So those are the two transformations we're talking about today. Simple transformation. We'll talk about two other ones tomorrow. The main thing that's going to show up in what will be like on your quiz on Friday is identifying transformations. So I'm going to show you something that's going to happen, and you're going to have to identify it. Like, is that this transformation? Is that this transformation? Is that a reflection or translation? So we'll practice identifying them. Next week, we'll practice graphing them and talking about their rules, actually. But we won't worry about that for now. So let's say we have this situation. What is going on with this transformation? How is this object being transformed? Alex?
It's a translation, just moving position.
So the translation. We start with our triangle XYZ, and we're sliding that triangle. We're moving it over to X prime, Z prime, Y prime. Or X prime, Y prime. So the only thing that is happening is it's changing location. So it's a translation. But the orientation staying the same. It's not flipped around. It's not spun around. It's not larger or smaller. It's still the same triangle. It's just slid a little bit. So that's a translation. Good. What about this one? What was that?
Reflection.
Reflection. Good. The mirror. Yeah. So this is a reflection. So that dotted line is our line of reflection that we're reflecting across. So we start with our word math, and then we have this line of reflection. And so we're reflecting across this line, and so it's flipping it down over here. Now the orientation is a little bit different because that line was at a diagonal. So when the line of reflection is vertical, like it was with that picture with the lady, it's easy to see the reflection. She just gets flipped across. When it's horizontal, it's easy to see they get flipped down. But when we start getting the diagonal lines, it becomes a little bit trickier, especially when we start graphing them. And so that will be something we'll practice in the future. But you take those letters and you flip them down. And remember, all these letters are equidistant. So H is equidistant from that line. T's are equidistant. The A's are the same distance. The M's are the same distance. They're just getting flipped down. Are we okay with this? Recognizing it's a reflection. Once again, this is the easy part. We're just identifying. Just looking at the transformation. What's going on with this picture? Okay. So what happened first? Translation. So we start with our triangle PQR, and we slid that triangle over, doing a translation. And then we're reflecting it. So we get P prime, Q prime, R prime, and then we flip it down. Where would that line of reflection be? If you were to draw it. Right below it, so right down here. In between the two. So it's going to be equidistant once again. So it should be right in between the two. So that would be our line of reflection. Most likely the line will be drawn for you, or I wouldn't require you to draw the line. But being able to recognize it is a good skill. In the future, when we're graphing, you might be given the image and the pre-image, and you said there was what is the wrong, or the image of this circle was reflected over a line. What is the equation of the line? And you would have to figure out, based off the location, they're both equidistant from this point, so that would be my line of reflection. And that will be something we'll practice in the future. But eventually you will sometimes have to draw that line. That could be a question they could ask on your state test. Would be draw this line of reflection, or what is the equation of this line of reflection? It might have been up for practice this year, actually. But yeah, that is a possibility. Right now, though, with identifying, don't worry about it, but it's a good thing to practice. What about this? What do you think? What do you think about this? So to start, we were just showing transformations by spinning it, turning it. What is different about this transformation than the other ones? What's different? So we start with capital letters, but we end with lowercase letters. What was one of the rules we had with translation, though? It doesn't change. So when we translate an object, when we turn it from one spot to another, we can't change the objects. We can't change the car, like we said. We can't change that triangle. It's the same triangle, but here we changed it. We changed the letters. The letters became lowercase. And so because of that, this would still be considered a transformation, but it wouldn't be considered one of the transformations we talked about. It's not. I wouldn't consider it a translation because it's not congruent anymore. That's word that we mean the same. The A isn't the same as the A from here. So we always want to make sure, especially with translation and reflection, that they always, always, always stay the same. It might be a little bit different how it's oriented or how it's located, but the shape in itself should stay the same. And so by changing from uppercase to lowercase, that would no longer be considered a translation. Are you okay with it? Sorry. Good. All right. What are some examples of transformations that you see every day, though, that you can think about? Car. How is a car transformation? So when a car drives, it's moving from point A to point B. It's sliding. It's translating. Good. What else?
What if something that is
What do you mean? Okay, yeah. So like as you move from one spot to the other, your location on your pencil tip is changing. It's changing. It's translating, but your pencil isn't. Is that what you mean? Good, good. It's a good way to think about it. What else?
move the desk?
Do you move the desk or do you push something? Yeah, walk your wheels. Do you move your desk? That's a translation. It's the desk isn't changing. You're just putting it from one side of the room to the other. What else? A mirror. So every time you look in the mirror in the morning, or whenever you end up looking in the mirror throughout your day, that's a reflection. You're looking at yourself. You're being reflected into the mirror or reflecting back at the mirror.
What if it's a mirror to a mirror?
So like a mirror reflecting a mirror. So like where you get those two mirrors and it's like infinite number of mirrors. Those would all be transformations. It would just be a lot of like infinite number of transformations happening over and over again.
Like that mirror. Yeah, it's solid. In the bathroom, the girls' bathroom on like the third grade side.
Can you think of any other transformations, maybe ones we didn't talk about today? Think about that star. What else did we do to that star?
People grow.
So molding clay and art, you're taking a clay object and you're changing it into something else. Well, what did you say?
People grow.
So we grew that star. We made it was smaller, we made it larger, we shrunk it. So people growing, that's an example. We call that dilation, is our word we use that we'll talk about tomorrow. So we dilate objects. Good. Can anyone think of other examples of dilation? Your eyes. So we still use the same word dilate. So if you take a flashlight and you shine it in someone's eyes, their pupils were large, but then they shrink because they don't need, it's absorbing a lot of sunlight, so it's trying to hide itself from all that sunlight, or that flashlight, or whatever you're shining. And so they shrink, they dilate. But if it's dark, your eyes need to absorb more light, so they'll get larger. So your pupils will dilate.
Scientifically proven if you look at something that is interesting that your life can be
No.
how it looks.
All right, so dilation. Can we think of other examples?
Whenever you bake bread,
Bake bread, it rises. Good. It grows. What other transformations did we do with that star besides making it shrink or grow?
we throw it a ball.
We flipped it like a reflection, or we flipped it upside down by rotating it. So rotation will be our fourth transformation that we'll talk about tomorrow. So you take an object and you spin it, and you can rotate it counterclockwise, you can rotate it clockwise, you can rotate it 90 degrees, you can rotate it 360 and come all the way back around. What are some things that we see that we rotate? Cranes, stuff like that. Spin from one side to the other. Yeah, that's a good example. What else? I'm sorry. Carousel rotates. Got merry-go-round. Hands on a clock rotate. The wheels on a car rotate. Is it still broken? It's not working.
No,
Okay, should be working. Okay. Let's say. Yeah, so those are all examples of transformations that we might see in real life. And that's where we'll end the lesson part for today. Yeah, those are the transformation part.